Alright, goobers, today we're going to learn about some nomenclature, because I know y'all are pretty booty at that. Alright, let's start with this one up here. First thing I want you to notice about this is that there is a double bonded oxygen up here. So what I want you to recognize is that is a ketone. And a ketone basically is when there's a double bonded oxygen and there's an R group on each side, basically at least carbons on both sides of it. And you pretty much just follow the same exact formula we've been doing. Find the longest chain, add substituents, look at priority groups, and just name it. So the first thing I want you to notice is 1, 2, 3, 4, 5, 6, 7, 8 is going to be an octane. But since it's a ketone, you're going to have to name it. So it's going to be 1, 2. So instead of octane, it's going to be oct and 2 one. But let's not forget about the substituents here. You have 1, 2, 3. Okay, so you have a methyl group here, 3, 4, 5. So 3 and 5 are where your methyl groups are. And since there's 2, it's going to be dimethyl. So it's going to be 3,5-dimethyl octane 2-one. Yes. And the next one here, I want you to notice the OH group at the end. That means that it's going to be an alcohol. And same thing as we've been doing. Let's count. 1, 2, 3, 4, 5. So that's 5. Meaning it's going to be a pentane, since there's no double bonds or triple bonds. But since there's an alcohol, it's going to be pentanol. And you're going to want to say that it's at the beginning, so you're going to say pentan 1-ol. But let's not forget about the iodine here. If you start from here, because the alcohol has higher priority, you want to start from one here. 1, 2, 3. So the iodine is on the third carbon. So it's going to be 3-iodo pentan 1-ol. Now, the next one, we have this very special cyclohexane here. So that's the first thing you're going to even put down. Cyclohexane. Now, after that, I want you to notice these two bromines. You can start from either one, you will get the exact same one. If you start from here, you go 1, 2, or whether you start from the bottom, 1, 2. It's going to be 1, 2 dibromo cyclohexane. Reason it's going to be dibromo is because there's two bromines, and that's how you get it. 1, 2 dash dibromo cyclohexane. Now I want you to look at this one. It's a cyclohexane with an alcohol and a halogen. The alcohol will have higher priority than the halogen. But the first thing we can always do is just say hexanol. Cyclohexane 1-ol. And then you'd want to add the halogen. So if you start from here, 1, 2, 3, 4. 4-chloro cyclohexane 1-ol. Now, I want to talk about amines here, and I chose one of the most difficult ones I could find. Now, this one does look intimidating, but it's really not that hard if you break it down. Same thing as we always do. Find the longest chain. Start from here. 1, 2, 3, 4, 5, 6, 7, 8. And I can already see the mirror, so it's going to be the same if I start from here and go this way, or here and go that way. So let's just do from here to here. So 1, 2, 3, 4, 5, 6, 7, 8. So the first thing I'm going to notice is that it's an octane. Next thing I want to notice is the NH2 here, the amine. And that lies on the 1, 2, 3, 4, the fourth carbon. So it's going to be octan 4 amine. Next, I want to talk about these substituent groups here. You have 1, 2, 3, 1, 2, 3. These are both 3, meaning they're both propyl groups. And start here. 1, 2, 3, 4, 4. 1, 2, 3, 4, 5. 4, 5 dipropyl octane 4 amine. Now, I want to look at this section here now. So now I want y'all to look at this one right here. First thing I want you to notice is that there is a double bond here, which makes it an alkene, not an alkane as we've been doing previously. So we would first do the same thing we always do, count the carbons. 1, 2, 3, 4, 5. So no, it's going to be pentene. And since the alkene is the highest priority in this one, it's going to be pent 1-ene. And then I want you to notice the iodines. They're both at the end. So 1, 2, 3, 4, 5. So it's going to be 1, 5 diiodo pent 1-ene. 1, 5 diiodo pent 1-ene. Next, this one here. This one, while it looks difficult, is actually not that bad when you really look at it. First thing you should notice is there's a double bonded oxygen here, which should tell you immediately this is going to be a ketone. Next, there's a ring, so it's going to be a cycloketone. And next, you're going to notice that there's two substituent groups here. So let's just break it down first. First thing I want you to do is count how many carbons are in this ring. Now, I'll do that for you because it's a pretty big ring. It's a 10 carbon ring, so it's going to be a decane. But since we have a ketone here, we're going to do this. Cyclo, dec, decan, 1-one. And then count from there. 1, 2, 3, 4, 5, 6 is where you meet your ethyls. As you can see, we have two ethyl groups, one here and one here. And since they're on the same carbon, that actually doesn't matter. You're still going to put 6 twice. You're going to do 6, 6 diethyl. Six, 6 diethyl cyclodecan 1-one. And next, I want to talk about this one here. This is a carboxylic acid. A carboxylic acid is when you have a double bonded oxygen, and next to it you have an alcohol. That is what makes it a carboxylic acid. The naming is basically the same as anything else we've done, except at the end you read anoic acid. I know that sounds a little tricky, but just give it a shot. 1, 2, 3, 4, 5, 6 carbons. Okay, so you have a hexane. But in this instance, it would be a hexanoic acid. And then you would add your substituents. And you count from the carboxylic acid because it has the higher priority. So 1, 2, 3, 4. So 2,4-dichlorohexanoic acid. Next, we want to move on to this little fella right here. As you can see, it is a cyclo, and there's 1, 2, 3, 4. 1, 2, 3. So a cyclopropane. But we have an amine here, so it's going to be cyclopropane 1-amine. Cyclopropane 1-amine. And from here, 1, 2, we can see that we have our fluorines. So it's going to be 2, 2 difluoro. 2, 2-difluorocyclopropane 1-amine. Next, we will go to the last one. This is an aldehyde. It is very similar to a ketone because there's a double bonded oxygen. However, an aldehyde has a hydrogen on one side and on the other side has an R group, whereas a ketone has an R group on both sides. And the difference is that an aldehyde will end with -ol. So let's do how we normally do. 1, 2, 3, 4, 5, 6. So it's going to be hex, hexane, hexane, hexanol. And then we would count starting from here because an aldehyde only has carbons going in one direction. So you would start from the aldehyde every single time, the oxygen. So 1, 2. So it would be 2-bromohexanol. Oh, my bad. Hexanal. And that's it.